So we've got, this is obviously what our picture of the ear that we're used to, but this is what we can't see. So this would be the ear canal, and inside of this ear canal, we've all got one. There is air in there, right? So of course, and as a sound, what is a sound wave? We talked briefly. We might not talk about what exactly a wave is, but briefly in terms of sound, it is nothing more than vibrations. Usually vibrations in the air. Um, so vibrations are passed from the air within the air in our surroundings, and then they get passed into the air that's in our canal. And those vibrations in the air in the canal make the tympanic membrane, otherwise known as the eardrum, vibrate. In doing so, if we zoom in here, we have the smallest bones in our entire body, which are these little ones here. I forgot the name of them. Don't know if they it doesn't say. These little bones are attached to or they're touching the eardrum, and they shake and vibrate in particular frequencies to mimic the sounds that we've heard, and those are attached to the cochlea, and the cochlea has got all these hairs inside of it, and those hairs vibrate. You can't see them; they're inside, and they vibrate depending on what frequencies there are. So you've got I'm not sure. I think maybe let's say the shorter hair ones might vibrate with higher frequencies, whereas the longer ones vibrate more with longer frequencies. And then you've got this nerve here, which will presumably be picking up the information and sending it to our brain about what sounds we're hearing. Now, here's the interesting thing. You may know that if you get a middle ear infection, you can lose your balance. If you have issues with your ears, you can lose your balance. So your ears are not just responsible for hearing sounds; they're also responsible for your balance. So how does it do that? Inside the cochlea, you have some liquid. This is where all the hairs are swaying back and forth. Imagine like seaweed in the bottom of the ocean swaying. And what happens is, let's say that I can't say for certain exactly how far this liquid goes, so I'm going to be guessing here. But let's say the liquid is filled up to this level here, right? Now, as you were to change the position at which you're standing, then just like water in a glass, it moves, it changes. It might then go more like this because you're leaning to one side. So around the outside of the cochlea, you have the different nerves, and you can see nerves up here. And these nerves and the hairs inside the cochlea are all picking up where the liquid is, and so it basically measures whether or not the liquid is high up here or high up here, or is it the same level everywhere? In which case you're upright. And so it determines whether or not you are about to fall over. So you can. So this is also, by the way, why if you spin yourself around, you get dizzy, because all this liquid starts to slosh around all over the place, and so you got your body, your ears get these confused messages where, in fact, your ears and your eyes get confused messages because your eyes are saying that everything's fine, but your ears are telling you that no, you're spinning around. So you got this confused messages from both your inputs. In fact, if you spin around and then close your eyes, it's particularly difficult because now the only information you've got is from this, and all the liquids kind of swirling all over the place, and it's not actually giving you the correct information. And that's also why when you spin around, it wears off pretty quick because eventually the liquid settles down. So it's a little bit like a spirit level. Don't know if you've seen a spirit level, but it works on the same sort of idea. If I had, let's say, a glass of water, so I'm going to this is how I'm going to make my glass of water. I'm going to turn that off like that and put it there. And then There we go. So here's a glass of water, upright, and I'm not going to be able to do it. Actually, I just realised I won't be able to do it if I lift it on its side. Let's just get rid of it. If I lift it on its side, the water is actually going to be it's going to be like this, isn't it? Right. So similar sort of thing is happening inside of our ears. That way we can see it's lower down here and it's higher up here, and so our brain works out that we're not standing upright. So yeah, that's basically what the cochlea does. Let me just stop that video.